Hi guys, it's Ms. Raposa, and I'm going over part 4 of the Unit 3 test review. This is the calculator section. Just a reminder that your mode should always be in radians for calculus. So just make sure that your mode is in radians. And then problem 16 says the graph of this function changes concavity at x equals where? So as soon as I see concavity, I know I want to be looking at my second derivative. So I'm going to ask the calculator to graph my second derivative. So into y1, I've put my original function. Down in y2, I'm going to ask it to take the derivative. I press math number 8, d dx. And then right here, we want to get y1. So where I get y1 on my calculator is green alpha trace. So green alpha trace, I get a pop-up menu and you should see y1. You're asking the calculator to take the derivative of y1. And over here on the right, you always want to put x equals x to graph a generic derivative. But I want the second derivative. So I'm going to go down to y2 and hit math 8 again. And I'm going to now take the derivative of y2 at x equals x. Now, I don't want to hit graph yet because it would graph all three of these. And so to turn the graphs off, I just scroll up to y1, press enter on the equal sign, and it's no longer highlighted. On y2, press enter on the equal sign, it's no longer highlighted. So in a moment when I press graph, I'm just going to be graphing the second derivative. And I'm going to be looking to see where the second derivative is 0, and not only where it's 0, but where it crosses the axis. It has to move from positive to negative or vice versa. Before you graph, you always have to check your window. So I'm going to hit window. And in this problem, they don't give me a window to use. So I just look at my answers. And I'm looking that my answers go from negative 2.3. They're all negative numbers. So I might choose negative 3 being my smallest x value. And I might choose 1. I usually like to see the origin, so I pick positive 1. But just make sure all your answer choices fit in that domain restriction that you pick. My y values don't really matter. Sometimes we like to zoom in on that on the x-axis. So right now mine are negative 3 to 3. And just a reminder, whenever you're graphing derivatives in general, your calculator moves a little bit slower. So to speed it up, down here at the bottom where it says xres, I like to bump that up to 3, so it graphs a little bit faster. So I'm going to hit graph. Remember, what I'm looking at is my second derivative. And it looks to me like the second derivative is 0 right there. And it's not only 0, but it's changing from negative to positive. So I have to find that value. So it is a 0. I'm going to press second trace, 0. Move your cursor to the left. And if you can't find your cursor, just look at those y values until you see it. My y values just turned negative. I'm going to press enter for the left bound. I'm going to move my cursor to the right until I'm to the right, or in this case, above the axis. Press enter. It gives you a guess. Always press enter again after it gives you a guess. And this scrolling up here, it's hard to see, but means that it is finding the answer. And the answer is 1.89. And so the answer is D. Okay, let's try set number 17. And there's different ways to do these. So if you have a different way and you still get negative 1.89, that is great. Number 17 says the first derivative of the function is given below. So that's really important to make note of, that they gave us the first derivative. And then it says, how many critical numbers does the function have on this interval 0 to 10? So critical numbers happen where our first derivative is 0, or where our first derivative is undefined. So because this is the first derivative, all I'm going to do is graph this function that they gave us. So I'm going to go back to y equals, and I'm going to get rid of everything that I've got in here. Back up to y1, I'm going to graph this first derivative. I like to grab a fraction. You don't have to do that, but the way that you do grab a fraction is green alpha y equals. Gives you a little fraction bar. And then I'm going to type in cosine squared, which how you do that is you do cosine Since it doesn't allow you to put a squared there, we put an X, close parentheses, oops, and square it. Hold on. X. There we go. Close parentheses and square it. On the bottom, it's just X minus green alpha y equals, I like to grab the fraction bar, it's not necessary, 1/5. Now before I hit graph, you always change your window. And this window is supposed to be going from 0 to 10. And I'm looking for how many critical numbers. So I'm really looking for when this derivative is 0 or undefined. So let's take a look. Okay, it's hard to tell. At least on my graph, it's hard to tell how many times it's 0. So that means I need to change my window and really zoom in and make these y values smaller. So I'm going to go back to my window, and I'm going to make my y values -1 to 1. And I'll see if that's enough. So let's hit graph. Ooh, that's still hard for me to tell right here. I'm going to go even further. My window, I'll put my y values at -0.5 and +0.5. And that's a lot easier for me to tell. How many critical numbers? 1, 2, 3. And so my answer is B. Okay, number 18. How many points of inflection? So as soon as I see points of inflection, I know I'm talking about the second derivative. I'm looking to see where it's 0. And I'm also looking to see that it changes from positive to negative. So it has to cross over 0 or negative to positive. And here's my function. So I'm going to go to y equals, and I'm going to type in that function, ln of cosine 2x plus 2. I need to get my second derivative. So I am going to do math 8 again. d dx, y1, x equals x. Same direction, same steps as I did on the very first problem. Math 8, d dx, this time of y2 at x equals x. Just like in our very first problem, we're going to turn off the first two graphs. So the only equal sign that should be highlighted is y3, which is the second derivative. And I am given a domain restriction of -2 to 5. So I'm going to go to my window, and I'm going to change my x's from -2 to 5. And let me read what the question says a little bit more carefully. It says, how many points of inflection? So I'm going to just be counting up when I hit graph how many times this second derivative crosses that axis or is 0. Okay, let me hit graph. My y min and max, I might want to change those. Those are pretty small from last time. I'll pick -5 to 5. Can always play with it later. Press graph, and I have 1, 2, 3, 4 times that I'm counting that this second derivative is 0, and not only 0, it's crossing the axis. So I'm counting 4 separate times, and so my answer is going to be C. Some of you might be asking, well, what's happening over here at -2? If I tried it out, -2, it's actually positive. Okay, it's not 0. And even if it was 0, it has to cross. So that's not going to work. All right, number 19. If you look, the first time I looked at number 19, I thought it was the same exact question as number 18, because it says how many points of inflection, and again, second derivative is 0, does the function f of x on the interval -2 to 5 have? But this time, look at what you're given. You're given f prime. So that means if I need to get to my second derivative, I only need to take the derivative one time. This is f prime. I only need to take the derivative one time to get me to f double prime. So I just adjusted my window so that I'm just graphing the derivative, which is really this f double prime. My window again is -2 to 5. and I'm going to hit graph. And I'm counting up how many times. Okay. 1, 2, 3, 4, 5 times. So my answer to number 19 is D. Okay. Last up, crooked here. Number 20 says, for which open interval on 0 to 5 is the function f increasing and concave up if the derivative is given as this? Okay, so we are given the derivative and we're asked some information. There's a lot of different ways that you could do this. I'm going to just graph that derivative that we're given. So I'm just going to go into y equals, clearing everything out, and into y equals, put that derivative in. Now we've done problems without the calculator where we look at the derivative and you're asked questions. You're asked, where's the original increasing? Where's the original concave up? And so we're going to apply the same rules that we applied when we did these problems without the calculator. So let me just set my window, and it says from 0 to 5. So I'm going to go 0 to 5. My y window is still on 0 to 5. So I'm sorry, it's still on -5 to 5. And that's okay, I think. I'm going to hit graph. Okay, keep in mind, this graph is the derivative. So I'm looking at f prime. I want to know, where is the original increasing? Well, looking at the derivative, the original's increasing wherever the derivative is positive. So all this stuff could be part of my answer to begin with. I also want to know where the original is concave up. Well, the original is concave up where the derivative is increasing. So just right here. So the overlapping part is from here to here. And I have to list the interval that's going to work for this. So let's look at our answer choices. This interval says 0 to, that could be it. This could be it. This could be it. D could not be it because I see on my calculator, this is my portion. Okay, my derivative is positive and my derivative is increasing, meaning it would be increasing and concave up. So I'm looking to see where f prime is positive and where f prime is increasing. So I need to find this maximum point. We just have to remember back to algebra 2 or maybe algebra 1, how to find a maximum on your calculator, maybe pre-calc. We hit second trace. The fourth one down is maximum. It asks you for left bound. We just scoot our cursor to the left of the maximum, press enter. Right bound, move your cursor anywhere to the right of the max, press enter. It gives you a guess. Do not write that guess down or do not think that's your answer. Press enter one more time and I get 2.02875, etc. B is going to be my answer.